Hi, everybody, and welcome to section 3.1, which deals with using problem-solving strategies. So let's just go over this really quickly. How do we use problem-solving strategies to solve word problems? So first we need to read the problem. We identify what we're looking for. We say, okay, this is what we're looking for, and we let the variable represent that quantity, okay? And then we translate it into an equation, solve the equation, check the answer, then you would write the answer. So, sometimes you can do multiple steps at once, which is fine, as long as you understand what you're doing. I think that's the most important thing. Okay, so let's do an example. We have Pilar bought a purse on sale for $18, which is 1/2 of the original price. What was the original price of the purse? So, okay, fine. So they're trying to find the original price of the purse. So I'm going to let X equal the original price of the purse, okay? And then it says, okay, fine. So then what do they give us? They give us that 18 is 1/2 of whatever the original price is, right? So we can write this as a sentence. We would say 18 is 1/2 of X. Okay, so then of course to solve for it, multiply by the reciprocal, which is 2. So multiply both sides by 2. That would cancel. 2 times 18 is 36. And so we know that the original price of the purse, so the original price for the purse of the purse was $18. Okay, not too bad. Okay, so Joaquin bought a book on sale for $120, which was 2/3 of the original price. What was the original price? This is the same kind of situation where we let the original price be X. So 120 is or was 2/3 of X, because the word of means multiplication. And then, of course, 2/3 means 2/3. And then was is a past form of is, right? Okay, so to solve, again, we multiply by the reciprocal. Okay, that would cancel this out here. You get X, and then this is over 1. What's half of 120? That's 60. 60 times 3 is 180. So the original price was $180. Okay. Okay, so then it says 2/5 of the songs in Mariel's playlist are country. If there are 16 country songs, what's the total number of songs in the playlist? So we let X equal the total number of songs, because that's what the question is asking us, right? Because the question is, what is the number of songs, total number? So that's what we're letting our variable equal. But then 2/5 of those songs are country. So 2/5 of the total, which is X, are 16, okay? So then solving for X, that part's not too bad, right? By now, you guys must be pro. So X is equal to, and then we have half of 16, which is 8. 8 times 5 is 40. So the total number of songs, there are 40 songs. Okay, let's do more because we love these. Jenny and her classmates formed a study group. The number of girls in the study group was 3 more than twice the number of boys. There were 11 girls. How many boys were in the study group? So let X be number of boys, obviously, yeah, by now. And then it says the number of girls was 3 more than twice. But how many girls are there? There's 11. So 11 was, or, past term of is, 3 more than twice what the number of boys is. We don't know. That's X. Okay, so just to get again, so the number of girls was 3 more than twice the number of boys. Okay, so we solve for X here. So subtracting both sides by 3, 11 minus 3 is 8 equals 2X. Divide both sides by 2, you get X is equal to 4. So there were 4 boys in the study group. Okay, Guillermo bought textbooks and notebooks at the bookstore. The number of textbooks was 3 more than twice the number of notebooks. He bought 7 textbooks. How many notebooks did he buy? So the question is how many notebooks, right? That's that's what they want to know. So let X equal number of notebooks. Do you guys kind of see how we're doing this? So X is the number of notebooks. We're just restating the question. We're letting the variable be what we're looking for. And then the number of textbooks was, so what's the number of textbooks? 7. So 7 being the number of textbooks was 3 more than twice the number of notebooks, which we define as X, okay? So then the next step would be just to solve for X. Subtract 3 from both sides. 7 minus 3 is 4 today. Bring this down. Okay, divide both sides by 2. Okay, X is equal to 2. So that means that he bought 2 notebooks. So at least writing the units of what we found here lets me know, hey, they know what they're talking about. You know what they're looking for. You're answering the question. Okay, so Jerry worked Sudoku puzzles and crossword puzzles this week. The number of Sudoku puzzles he completed is 8 more than twice the number of crossroads. He completed 22 Sudoku puzzles. How many crossword puzzles did he do? So again, we define a variable. Crossword puzzles, yeah? Number of crossword puzzles. Okay? Now the number of Sudoku puzzles is given to us. There's 22 of them. So 22 is, there we go, 8 more, there it is, twice the number of crosswords, which we let be X, okay? And then we just solve for X. So minus 8. So 22 minus 8 is 14 today, equals 2X, divide by 2. We get X is equal to 7 crossword puzzles, so 7 crossword puzzles. Okay, now I like these because these are really nice because they're just straight up. So the difference, that means we know we're going to talk about subtraction, right? Of what? What's the difference of a number and 6? So we don't know what the number is, so we let X equal the number. And so we say the difference of a number and 6 is 13. Find the number. Not too bad, right? So then just solve for X. X is equal to 13 plus 6 is 19, and that's it. Okay, or you could use N. So I'm going to do a couple more of those because those are good. So remember, you can pause this and, work these problems out also. And then come back to it. So difference between a number. So difference means that it's subtraction. And what are we subtracting? We're subtracting a number. We're taking the difference between a number and 8 is 17. So find the number. So let's just first set them up and then we'll solve it. Okay, so this next one, the difference between a number and 11, so X minus 11 is negative 7. Okay, what about this one? This one, well, let's first do the difference ones. Let's solve them. So then all we need to do to solve these is just add both sides, right? So X is equal to, in this case, this is 25. How about here? Let's add 11, right? So X is equal to 4, okay? And now this one, now let's talk about this one. The sum, so we're going to add 2 things, but what are we adding? We're adding twice a number and we're adding 7 together. So here's 7, twice a number. We don't know what the number is. That's actually what we're trying to find. So 2x or 2n, okay? So the sum of twice a number and 7 is, there's that is, 15. So not too bad. Now we're going to solve it. Minus 7 minus 7. And then 2x is equal to 8. So divide by 2. And we get x is equal to 4. Or n is equal to 4. Okay, let's do a couple more. We have here the sum of 4 times a number and 2 is 14. So we have the sum, 4 times a number. We know that that's 4x. And 2 is 14. Okay. So then we have the sum of 3 times a number. So, oh no, let's solve it first. So minus 2, sorry, minus 2 minus 2, right? 4x, bring that down. 14 minus 2, bring the equal sign is 12. Divide by 4, we get x is equal to 3, okay? The sum of what? 3 times a number and 7 is 25. So find that number. We need to subtract 7 from both sides. So 3x is equal to 18. Divide by 3, divide by 3. We get x is equal to 6. Okay? All right. Now it says one number is 5 more than a different one. The sum of the numbers is 21. Find the numbers. So there's two numbers. So let x equal the first number. But then what is the second one? It says one number is 5 more than the other. So the other one, so it doesn't matter which one, right? Because you can say this is the first, this is the second. So if I say the another is the first one, the other number is going to be 5 more than that. So, and then I just care about adding them. So the sum of the one that's 5 more and the original is going to be 21. So then from here, we just like terms. And then simplify by subtracting both sides by 5. We get 2x is equal to 16. Divide by 2. And we get x is equal to 8. Okay, and then I want to talk about consecutive integers. It says some number problems involve consecutive integers. So consecutive integers are integers that immediately follow each other. So let's say, for instance, here you have 1, and then immediately after that is 2, and immediately after that is 3 and 4. If you're on the number line, basically, you can imagine a number line, and then you can imagine the numbers that are going to the right. So you have -10, to the right is -8, -7, okay? So basically, when you think about consecutive integers, each number is one more than the one before it, okay? So if the first integer is n, the second one is going to be n plus 1, and then the third one will be n plus 2. Okay, so these consecutive integer problems are not going to go away. So don't let that consecutive integer word scare you, okay? All it means consecutively means one after the other, right? So if you have 1, 1, the next consecutive one is 2, the next one is 3, the next one is 4, and so on, okay? So let's see here. So this setup is really important. Okay, so let's do the next one. So the sum of two consecutive integers is 47. So if we let n be the first one, then the next one is just going to be plus 1. Second consecutive integer. Consecutive integer, right? So the sum of these two, so n plus 1 is going to equal 47. Okay? So let's do like terms. We get 2n plus 1 is equal to 47. I don't know why I'm having, okay, minus 1. And then we get 2n is equal to 46. Divide by 2, n is equal to 23. So that's the first one. What about the second one? The second one, so number one, so first number, you can do it like first number, 23, and then the second number is 24, yeah? Because n plus 1 would equal 24, okay? It's just the one right after it. Okay, the sum of two consecutive integers is 95. So that means, again, so let's say x is the first, and then x plus 1 is the second. Okay, so x plus 1 is 95, okay? So 2x plus 1 is equal to 95, so then we're solving for x. We get 2x is equal to 94. Divide by 2, we get x is equal to 47. So then the next one, so the numbers would be 47 and 48, and you would circle this, okay? Because it says to find the numbers, not just one number. Okay, so let's do a super fun other example. So let's find 3 consecutive integers whose sum is -42. So fine. So if n is the first, n plus 1 will be the second, and then n plus 2 will be the third, okay? Just because, think about it. And 4 is 1 more than 3, 5 is 1 more than 4, and so on. And that makes sense here. So we just added 1 to each time. So the sum of these, n plus 1 plus n plus 2, the sum of all those 3 is -42. Okay, so now what do? We do like terms. So there's 3 n's, okay? And then you have a 1 and a 2 here. So plus 3 is equal to negative 42. Subtract both sides by 3. We get 3n is equal to negative 45. Divide by 3. We get n is equal to negative 15. So if this is the first integer, right, n is the first, the next one, so first integer, you know, is going to be negative 15. The second one is going to be the next one on the number line, right? So that's going to be, if you even need to write it out, you need to write n plus 1, that's fine too. Negative 15 plus 1, that's going to be negative 14. The third one is going to be, you guessed it, negative 13. But you can go ahead and plug it into n plus 2 if you want. That's fine. Negative 15 plus 2, you're still going to get negative 13. Okay, so think of it on the number line. Okay, so if you have negative 15 here, the next number, the consecutive integer is negative 14, and the next one is negative 13. Okay. Okay, now when you have consecutive integers, you can also think about consecutive even and consecutive odd. Okay, so let's look at some integers here. You have 18, 20, 22, 64, 66, 68, negative 12, negative 12, negative 12, negative 10, negative 8. How about consecutive odd, 3, 5, 7, 9, So do you notice something here? So notice how many numbers does it take to go from 3 to 5? I have to add 2. How about 5 to 7? I have to add 2. So 7 to 9 plus 2. Same here, plus 2, plus 2. So you can see that consecutive even or odds, it's 2 apart. So when you have consecutive even or consecutive odd, n would be the first one, the next one would be plus 2, and the next one would be plus 4. Okay? So it's the same thing, consecutive even and consecutive odd, okay? So it doesn't matter if it's even or odd, you still have to use n plus 2, n plus 4. Now make sure you understand that, because a lot of people get that confused. They go, well, it's odd, so I have to add 1, 3, and 5. No. That's not true, because look at the number line. On the number line, you have 1, 2, 3, 4, and 5. So you have, this is my first integer that is odd. Here's the other one, and here's the other one, right? They're 2 spaces apart. Now, what if we do evens? Here's my first even. Here's the second even. They're also 2 spaces apart, which is why we set them up the same way. Okay, so let's do a super fun example. Let's find 3 consecutive integers whose sum is 80, even integers whose sum is 84. So n is the first. So then n plus 2 will be the second consecutive integer, even integer. Consecutive even integer. And then n plus 4 will be the third consecutive even integer. Now the sum of all of those is going to be 84. So your sentence is n plus 2 plus n plus 4, and that's going to equal 84. Okay, so now how do we solve this? We take like terms. So we have 3n, and then you have 2 plus 6 is equal to 84. And then we're solving for n. So let's go ahead and subtract 6 from both sides. We get 3n is equal to what? 78. Then divide by 3. And n is equal to 26. So that's the first consecutive integer, right? Even integer, sorry. So you have 26. The next one is 2 more. So the next even number is going to be 28. And then the third one will be 30. Okay? So that's that one. Okay, last problem. We're doing an average cost here. So last problem we have, according to the National Automobile Dealers Association, the average cost of a car in 2014 was $28,500. This was $15,000 less than 6 times the cost in 1975. What was the average cost of a car in 1975? So first of all, what's the question asking? The question is asking the average cost of a car in 1975. So what are we going to let x equal? You guessed it, average cost of a car in 1975, right? We're basically restating the question, but we're saying, okay, what you're asking for, that's my variable. So X is average cost of car in 1975. Now, what did they give us? In 2014, it's 28,000. 28,000 is, so 28,000 what? 500, sorry, was 1,500 less. So 1,500 less than, that means I'm subtracting it from, what am I subtracting it from? 6 times the cost in 1975, so 6x. Okay, so let's go through that again. 28,500 was, so here it is, directly translated to symbols. 1,500 less than, that means I'm subtracting it from something, that's right there. 6 times here, the cost in 1975, which we already said is represented by x. So 6x, so that's right there. Okay, so now to solve this guy, what do? We have to use addition property, right? So then that cancels out here on the right-hand side. We bring this down 6x. What's 28,500 plus 1,500? That's going to be 30,000. Okay, and then divide by 6, and we get that x is equal to 5,000. Okay, so the average cost of car in 1975, so average cost of a car in 1975 was $5,000, and we wish, right? I wish. Okay, okay, that's it for section 3.1. Here are your exercises. That's what you need to do, the odd problems. And then if you want extra credit, make sure you share your answers for number 1 in your discussion section for the week, okay? Okay, good luck, happy studying, and I will see you on the next video.